Using a hidden Markov model, our sketching system learns refinements from a set of examples that exhibit a desired look, in this case, coastlines. These learnt refinements are then used to augment the tangent angles of a coarse input curve. In order to keep the output curve close to the input, we include an additional bias that simulates a magnetic attraction. To allow the output to diverge a bit while still maintaining closure, we relax this bias when away from the endpoints. The synthesis procedure is invariant to both the starting point and direction of the input stroke. When the input curve attempts a transition that is not seen in our training examples, the method picks the most likely mixture of examples that accomplishes that transition. Here, it chooses a segment of a circle to help transition between two examples. Our approach takes into account the entire input curve when choosing a solution. Note how new points can affect the previously chosen solution. Sometimes this effect is only local, other times it could change the entire output curve, reflecting a more likely solution. Our system is generic over curve attributes. This allows us to seamlessly model supplementary curve behaviors. To avoid unnecessary transitions, we include an additional regularization term that penalizes transitions from one example to another. In this example, the system learns and generates texture seeds that are later used in a Markov random field texture filler. The end result is overlaid over the generated background. To synthesize complete scenes consisting of multiple curve strokes, we first need to identify what refinement model to use for each curve. This is accomplished in two ways. First, for a given curve stroke, we examine the likelihood of each refinement model based on the shape of that curve. Then we condition the likelihoods based on the semantic relationships the curve has with respect to other curves on the scene. In this example, the graph shows the semantic constraints applied on each set. The letters indicate that we care about the relative position. A for above, B for below, L for left, and R for right. Similar to the curve level HMMs, at the scene level, the entire sequence of curve strokes is considered. Future points have effect on past solutions. Note how the original solution of a grass style is changed to a water style when we draw something that, in most likelihood, belongs to the fish class.